Here's a discussion question, or a question for you to think about. Let's say we want to generate a table with one row per cafe that has the name and discounted price of the cheapest discounted drink at that cafe. So we start with the drinks table, where we could have multiple drinks for a cafe. We also have the discounts table, where we could have multiple coupons per cafe. We're only interested in cafes that have drinks with coupons so that we can get a discounted price. And what we want is one row per cafe that writes down the discounted price of the cheapest drink they have. So that means we need to look through all of Nepheli's drinks, espresso and coffee, find the least expensive one, discount that appropriately, and see that we could get out the door for only $1 with an espresso in hand. And a T1, if we discount as much as possible their one drink, we can get it for $3. So these are the cheapest things offered by Nepheli and T1, and here are the drinks that we get. How do you do it? Why don't you spend some time trying to think about what are the steps that would get you from the first two tables to the third table, and then we'll go through it together. Pause the video if you want to keep working on your own. We're going to start working on it together in 3, 2, 1. Here we go. Here's the drinks table from the slide, the discounts table from the slide. We're certainly going to need to join them together. And we join on the location of the cafe. That's where we see similar values in this table and this table, just like before. So we can say drinks.join on cafe with the discounts table, which calls its cafe's name location, and we get the following result, which is all of the different discounted drinks. Now we need to know the price of those discounted drinks. So let's give this result a name. And then we can add another column, the discounted price column. And we have to compute this from the columns of A. So this gets A's price, multiplies it by whatever's left over when you're done with the discount. 1 minus A dot column number 3 divided by 100. Let's see what we have now. We have the discounted price. Looks right. There's the row we want, there's another row we want, and now the question is, how do we get just Nepheli Espresso 1 and T1 Milk T3? Now, of course, there's a simple way. We could just take those rows, but we want an expression that would work even if the set of drinks and the set of coupons were different. Something that would work generally for any set of cafes and any set of drinks and any set of coupons. Before we proceed, let's think about what information is required in order to compute the result. We need to know the cafe's name so that we can find unique values of the cafe. The drink names are required in the output. The discounted price is needed because it's required from the output and tells us which one is the cheapest drink. And these other two aren't needed at all. So I'm going to change A to drop columns 2 and 3 so that I'm left only with the information that's relevant. Now let's see, if I sort by the cafe name, then I'm left with only one row per cafe, but I didn't get the cheapest drink. So that's not quite right. If I group by the cafe name, I would get the counts. That's not useful. But if I provided an aggregation function, then I got close. I figured out that the cheapest thing I could get at Nepheli was 1 and a T1 cost 3. But I got the wrong drink. This is the minimum drink from Nepheli, which is the first one in alphabetical order, which is coffee. So notice that when I grouped and took them in, I ended up with a price for espresso and the drink called coffee. And these two values don't have anything to do with each other. Instead, they're just the minimal value from here, coffee comes first, and then the minimal value from here, 1 comes first. And so I ended up with something that doesn't exist, a $1 coffee. Because coffee costs $1.50. So we still haven't gotten to a solution. Here's something you could do. You could sort by the discounted price. Now we see the cheapest things at the top. And then we could sort again by cafe, only to get the distinct rows, one per cafe. There is the result I want. I kept one row per cafe after sorting to make sure that that one row at the top of the list would be the one with the lowest discounted price, which I achieved by sorting by discounted price. So there's a solution to this problem. And it illustrates how you can combine existing ideas about table manipulation in new ways in order to get results that aren't built in, meaning they have just one function that does all the work, but instead require a combination of sorting and dropping and joining in order to get the final result that we're looking for. And this composition of table methods is very common whenever you're working with data.